Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area of compound shapes practice questions. If you need any extra help on area of compound shapes, if you go to Corbettmaths and you scroll down to videos and worksheets and you look at videos number 41 and 42, there's dedicated video tutorials there on area of compound shapes. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1, it's a non-calculator question, and we've been asked to calculate the area of this shape. So we've got this compound shape, so two shapes put together, and we've been asked to calculate its area, so let's split it into two smaller shapes. Now we could cut it down here vertically like so, and you'd have this square and this rectangle here. Alternatively, you could cut it across horizontally here and have this rectangle and this rectangle. I'm going to cut it down vertically here, so you can see here we've got this now square on this side because it's 3 by 3, so that's a square there, and we've got this rectangle. So let's find the area of each of these shapes. So what I'm going to do is I'm going to find the area of this rectangle, and I'm going to find the area of this square, and we're going to add them together, and that'll be the area of the whole shape. So let's start off with this rectangle here. Now in terms of this rectangle, we know the length of it is equal to 9 centimeters, but we don't actually know the width of this rectangle. But here, if we look, the width of the whole shape is 8 centimeters. The width of this part is 3 centimeters. So this plus 3 would have to be equal to 8. So that means that this width here would have to be, this length here would have to be 5 centimeters, because 5 centimeters plus 3 centimeters is 8 centimeters. So we've now got the length and the width of this rectangle, and we've got the length and the width of this square. So let's find the area of those shapes. So let's start off with the rectangle, so shape 1. So in terms of shape 1, to find the area of the rectangle, we do the length multiplied by the width. So the area would be equal to the length, which is 9, multiplied by the width, which is 5. So 9 multiplied by 5. And 9 times 5 is equal to 45. So that means the area of the shape would be 45 centimeters squared. In terms of the square, again, we're going to do the length multiplied by the width, so the area would be equal to the length, which is 3, times the width, which is 3, so 3 times 3. Or you could just do 3 squared, square one of the sides for square. So 3 times 3 is equal to 9, so that's 9 centimeters squared. So we've now got the area of this part, that's 45 centimeters squared. We've got the area of this part, which is equal to 9 centimeters squared. Now let's add them together, and that'll be the area of the shape. So 45 plus 9 is equal to, well, 45 plus 10 is equal to 55. So 45 plus 9 will be equal to 54 centimeters squared. So that means the area of this whole shape would be equal to 54 centimeters squared. And that's it. So what we done was we cut it into a rectangle and a square, found the area of each of those, and added them together. Now, alternatively in this question, rather than cutting vertically like so and getting this rectangle and this square, we could have cut across horizontally, and that would have given us a rectangle and a rectangle here, and we could have worked out the area of each of those and added them together, and again we would have got 54 centimeters squared. Okay, let's look at our next question, question number 2. So question number 2, we've got this L shape, or looks like an R, but it's an L shape if you spin it around. So we've got this shape, and we've been asked to calculate the area of the shape. So again, we need to split it. We need to either split it here horizontally or vertically. We could do either way. I'm going to cut it across here horizontally. So we've got this rectangle here, and we've got this rectangle here, and we need to find the area of each of them and then add them together. Now here we've got this rectangle here. Now in terms of this rectangle at the top, its length is 10 and its width is 4. So 10 multiplied by 4 would be equal to 40 centimeters squared. So that means the area of this part is 40 centimeters squared. Now in terms of this part down here, we've got another rectangle, and in terms of this rectangle here, we've got its width is 2 centimeters, but we really want to find how long it is, because this 13 is the whole height of the shape, but we just want to find this part here because this rectangle, this part's not equal to 13 centimeters. Now if we look at the height of the whole shape, the height of the whole shape is 13 centimeters, and the height of this part, or the length of this part, is 4 centimeters. 13 take away 4 is equal to 9, so that means the length of this part here must be 9 centimeters, so 9 centimeters. So to get the area of this part, we're going to do 9 multiplied by 2, the length multiplied by the width. And 9 times 2 is equal to 18 centimeters squared. So that means the area of this part is 18 centimeters squared. So we've got the area of this part, this rectangle, we've got the area of this rectangle. So to get the area of the whole shape, we just add them together. So 40 plus 18 is equal to 58 centimeters squared. And that's it. That's the area of this compound shape. Okay, let's look at our next question, question number 3. So question number 3, we've got this compound shape. It looks like a T shape, capital T, and we've been asked to find the area of this shape. So in terms of this shape, what I'm going to do is I'm going to cut it across here horizontally. So we've now got a rectangle on the top and a rectangle beneath, where actually this is a square beneath because it's 5 by 5. And we're going to find the area of each of these. So let's find the area of the top to begin with. So in terms of the area of this rectangle on the top, we need to find the whole length of it. We've got the width of it is 4 centimeters. We now need to find the length of that rectangle. Now in terms of the length of this rectangle, we've got 4 centimeters to here. So from here to here is 4. Then we've got another 5 centimeters, so that's 5 centimeters, and then 3 centimeters. So if we do 4 plus 5 plus 3, so 4 plus 5 is 9, plus 3 is equal to 12. So that means the whole length of this rectangle will be 12 centimeters. So we've got the length of the rectangle, and we've got the width of the rectangle. So if we now do 12 multiplied by 4, that's equal to 48 centimeters squared. So we say this rectangle, the top is 48 centimeters squared. Now we need to find the area for this square. Now it's a square because it's 5 by 5, so the length is 5 and the width is 5. So if we do 5 multiplied by 5, that's equal to 25 centimeters squared. So the area of this square is 25 centimeters squared. So we've got the area of the rectangle, we've got the area of the square. Let's add them together to find the area of the whole shape. So 48 plus 25, let's see what that gives us. So 48 plus 25 is equal to 73, so that's 73 centimeters squared. So there, this whole shape would be 73 centimeters squared, and that's it. Okay, let's have a look at our next question, question number 4. So question number 4, we've got this compound shape, and we're told the area of the compound shape is 106 centimeters squared. We've been asked to find the length of this side here, the length of this side labelled x. Now we know the area of the whole shape is 106. Now what I'm going to do is I'm going to split it into two rectangles. We've got this rectangle here and this rectangle here. Now the area of this rectangle, 7 multiplied by 10, is equal to 70 centimeters squared. So that means the area of this rectangle is 70 centimeters squared. Now, we know there the whole shape is 106. So if we do 106 take away 70, that's equal to 36 centimeters squared. That means the area of this part, this rectangle here, would be 36 centimeters squared. Now, this is fantastic because we now know the width of this rectangle and we've got the area of the rectangle. So if we do the area divided by the width, that'll give us the length of the rectangle because 4 times this would have to be 36. So 36 divided by 4 is equal to 9 because 9 times 4 is equal to 36. So that means the length of this side would be 9 centimeters, and that's it. That's the length of that side. So in this question, what we done was we split this compound shape into two rectangles. We found the area of the rectangle that we could find the area of, which was 70 centimeters squared. We took that away from the whole area, and that left us with 36 centimeters squared. And then we just considered, well, 4 times 9 is 36. That must be 9 centimeters, and that's it. Okay, let's look at our next question, question number 5. Okay, so question number 5 says Connor's painting the front of his house. So this is the front of Connor's house. So it's a little sketch of his house. And it says that a tin of paint that he has can cover 16 meters squared, so 16 square meters. And the question says, does he have enough paint? You must show your workings. So in terms of this question, we're assuming that he's not painting the door and painting the window. So he's just painting the walls of the house, so this white bit. So let's find the area of this white shape here. So to find the area of this white shape, what we're going to do is we're going to find the area of the whole rectangle. We'll find the area of the door. We'll find the area of the window, and we take the area of the door and the area of the window away from the area of the whole wall. And what's left? Well, we'll then see if it's bigger or smaller than 16 meters squared. So let's start off with the whole wall. So the whole wall, well, it's 7 meters long or wide, and it's 3 meters high. So 7 multiplied by 3 is equal to 21 meters squared, or 21 square meters. So that's the area of the whole front of the house. But he's not painting the door, so let's find the area of the door. So the area of the door is a rectangle as well, so we're going to do 2 times 0.9. So 2 multiplied by 0.9, well, double 0.9 would be 1.8 meters squared. So that means the area of this door is 1.8 meters squared. So that's the area of the door. Now let's find the area of the window. So that's going to be 2 times 1.3, so 2, and let's just set this out a bit better. So we've got here. So just labelling this, we've got the whole front of the house is 21 meters squared. The door is 1.8 meters squared. And in terms of the window, so let's write window. For the window, it's going to be 2 multiplied by 1.3. So 2 multiplied by 1.3 and double 1.3 would be 2.6 meters squared. So we've now got the area of the whole front of the building. We've got the area of the door and the area of the window. Well, let's take these away from the area of the front of the house. So let's add these together to begin with. Now, this is a non-calculator question, so we're going to do 1.8 plus 2.6. So 8 plus 6 is equal to 14. So put our 4 down, carry our 1. 1 plus 2 is equal to 3, plus another 1 is 4. So that means the area of the door and the window combined would be 4.4 meters squared. Now the whole front of the house is 21 square meters, so 21.0 subtract 4.4. Let's see what that's equal to. So 0 take away 4, let's borrow. So that's now a 0 and a 10. 10 take away 4 is equal to 6. 0 take away 4, well, we're going to borrow again. 10 take away 4 is equal to 6, and we've got our 1 there. So that's 16.6 meters squared. So if we have a look here, that 16.6 meters squared would be the area of this white region here. That's how much he needs to paint. He needs to paint 16.6 meters squared. That's how much he's got to paint there, this white area. But the tin of paint that he's got can only cover 16 meters. He's actually a bit short. He can't cover the whole front of this wall, obviously excluding the windows and doors. So he hasn't got enough paint. Let's explain that. And that's it. I've just written no, he needs to cover 16.6 meters squared or square meters, but he only has enough paint to cover 16 square meters or 60 meters squared, so he doesn't have enough paint, and that's it. Okay, so question number 6, we've got this compound shape, we've got this rectangle, and we've got this triangle on top, and the question says calculate the area of the shape. So we want to find the area of the shape. So let's split it into a rectangle and a triangle. So we've got this rectangle and we've got this triangle. So let's start off with the rectangle. So with the rectangle, its area is equal to the length multiplied by the width. So the length of the rectangle is 8 and the width is 6. So we're going to do 8 multiplied by 6 is equal to 48 centimeters squared. So that's the area of the rectangle, 48 centimeters squared. Now in terms of the triangle, so let's write triangle. The area of a triangle area is equal to half the base times the height. So half the base times the height. Now in terms of this triangle, we've got the height, the perpendicular height, that's equal to 5 centimeters. And in terms of its base, that's the length of the base. So if we have a look at the base of this triangle, it's going to be the same as this length, so that's 6 centimeters. So that's 6 centimeters, that's the length of the base. So in terms of the area of this triangle, we could do half the base, which is 3, and then times the height. 3 times 5 is equal to 15. Or we could do 6 times 5 is 30, and then half it to be equal to 15 centimeters squared, and so on. So in terms of the area for the triangle, it's going to be half the base times the height. So I'm going to do half the base times the height. So that's 6 times 5, the base times the height. 6 times 5 is 30, so half of 30, and a half of 30 is equal to 15 centimeters squared. So the area of this triangle is 15 centimeters squared. So just remember, you do the base times the height and then half it, or half the base times the height. So we've now got the area of the rectangle and we've got the area of the triangle. Let's add them together to find the area of the whole shape. So that's going to be 48 plus 15. So 8 plus 5 is equal to 13, put our 3 down, carry our 1, and 4 plus 1 plus 1 is equal to 6. So it's going to be 63 centimeters squared, and that's it, that's the area of that shape. Okay, let's have a look at our next question, question number 7. So question number 7 says the shape below is made from 5 identical squares, because if we have a look here, we've got these squares. If we split this sign, it looks like the add sign. If we split this sign up into squares, we've got 1, 2, 3, 4, 5 identical squares. And the question says the area of the shape there, the whole shape is 180 centimeters squared, and we've been asked to work out the length of this side here. Now if we have a look here, we've got the area of the whole shape, so the whole shape has got an area of 180 centimeters squared. Now because there's 5 identical squares, if we divide that by 5, that'll tell us the area of each one of the squares. So let's take the 180 and divide it by 5. So we're going to do 180 divided by 5. So let's do our bus shelter method, 180 divided by 5, because it's a non-calculator question. How many 5s go into 1? 0, remainder 1. How many 5s go into 18? That'll be 3. 3 5s is 15, remainder 3. And how many go into 30? That's going to be 6. So that means that each square has got an area of 36 centimeters squared. So that one's got an area of 36 centimeters squared. This one's got an area of 36 centimeters squared. This one's got an area of 36 centimeters squared. This one 36 centimeters squared, and this one 36 centimeters squared. Now we've been asked to calculate the length of one of the sides. Now if we consider a square, well, the length times the width, or the length times itself, is equal to its area. So here we're going to do 6 times 6 is equal to 36, because 6 times 6 is equal to 36. So that means the length of this side would be equal to 6 centimeters. Or another way to consider that is, if you know the area of the square, if you do the square root of that, so the square root of 36, that's equal to 6. So that's 6 centimeters. So the length of this side is 6 centimeters. And if you got that, well done. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 8. So question number 8, it's a calculator question, so you can pick up your calculator. And we've got this shape here. It says the diagram represents the side view of a shed with a sloping roof. So we've got this sketch, it's an ultra under scale, of the side of a shed with a sloping roof. And we've been asked to calculate the area of the side view of the shed. So we need to calculate the area of the shape. So to do that, it's a calculator question, so that's quite nice. Okay, so let's cut it. Let's cut it into a rectangle and a triangle. So if we cut it across here, we've got this rectangle and this triangle. So let's find the area of the rectangle to begin with. So the area for the rectangle will be the length times the width. So we're going to do 2.1 multiplied by 1.8. And it's a calculator question, so you can pick up your calculator and work that out. So 2.1 multiplied by 1.8 is equal to 3.78. So that's 3.78 meters squared, making sure we put the right units there, not centimeters squared, it's meters squared in this question because it's a shed. So 3.78 meters squared, that's the area of this rectangle. Now in terms of the triangle, we want to find the area of the triangle. Remember, it's half the base times the height. So the height of the triangle is 0.8 meters. We now need to find the base of the triangle. And if we have a look here, this length would have the same length as this length because this is a rectangle. So that's 1.8 meters. So this would be 1.8 meters. So we want to find the area of this triangle, so we're going to do half the base times the height. So we're going to do half the base, so half of 1.8, then multiply that by 0.8. We could also, remember, do 1.8 times 0.8 and then half it. It's a calculator question, so you can do it however you wish. So half of 1.8, that's equal to 0.9 times 0.8 is equal to 0.72 meters squared. So the area of this triangle is 0.72 meters squared. And that's fantastic. We've now got the area of the rectangle and the area of the triangle. We now just need to add them together. So we're going to do 3.78 plus 0.72, and that's equal to 4.5. So 4.5 meters squared. That's the area of the side of the shed. And that's it. So 4.5. And if you got that, well done. Okay, let's look at our next question, question number 9. So question number 9 says, shown is the plan of a small field. So here we've got the small field, and it says Thomas is going to keep some chickens in the field. So he's going to keep some chickens in this field, and each chicken needs 5 meters squared. So he wants to give the chickens enough space, and then at least 5 meters squared each. And the question says, work out the greatest number of chickens that Thomas can keep in the field. So to do that, we want to find the area of the field, and to find the area of the field, we want to find the area of this compound shape. Remember, this worksheet's on area of compound shapes. Now we could split this shape in different ways. We could cut it across this way. So you could cut across this way, and that would give you a rectangle and a trapezium. And you could find the area of the rectangle by doing 11 times 14 and find the area of that rectangle. In terms of the trapezium, remember the area of a trapezium is a half bracket a plus b times h. So that's where you'd add together the length of the two parallel sides, which would be 14 and 20, half that, and then times it by the height, so the distance between those two parallel sides. And you can work that out, because if this is 18 and that's 11, that would have to be 7. So you could do it that way. Now in terms of this question, I actually wouldn't cut it horizontally there. I would actually cut it vertically. And the reason I would cut it vertically is you've now got a rectangle here and a triangle, and they're just a wee bit easier to find the areas of. So in terms of this rectangle, it's 14 meters wide and 18 meters high. So if we do 18 multiplied by 14, that's the area of the rectangle. That's a calculator question, so that's really nice. 18 times 14 is equal to 252 meters squared. 252 meters squared. Now in terms of this triangle, the area of the triangle is half the base times the height, so area equals half the base times the height. In terms of this triangle, we need to find the base and the height. So in terms of the height of it, if the height of the whole shape is 18 meters, or this length of the field is 18 meters, if this length is 11 meters, this length must be 7 meters, because 7 plus 11 is equal to 18. So we've got the length of this line here, the height of the triangle. We now need to find the base of it. Remember, if you turn your head around, that would be the base, or however you want to consider it. So here, the whole width of this field is 20 meters. And if this width here is 14 meters, 20 take away 14 is equal to 6. So that means that from here to here, that distance from here to here would be equal to 6 meters. So from here to here, 6 meters, because 6 plus 14 is equal to 20. So if we have a look at this triangle now, we've got the base of it. If we turn our head around, that could be the base, and that's the height. And so we're doing a half of 6 times 7. So half of 6 is 3, times 7 is 21. Or you could do 6 times 7 is 42, and then divided by 2 is equal to 21. So 21 meters squared. Let's write that down. So it's a half of 6 times 7. 6 times 7 is 42, so half of 42, and a half of 42 is 21 meters squared. Or you could just do 0.5 times 6 times 7 on the calculator, or half times 6 times 7 on the calculator, and that'll give you 21 meters squared as well. So if we now get the area of this triangle, we've got the area of the rectangle, so let's add them together. So 252 plus 21 is equal to 273 meters squared. That's the area of the whole field. Now each chicken needs 5 meters squared. So if we take the area of the whole field, 273, and we divide that by 5, that'll tell us how many chickens can fit into the field, or have enough space in the field. So 273 divided by 5 is equal to, that's a decimal number, 54.6 chickens. Now obviously we can't have 54.6 chickens in this field. We can't put 55 in the field because that's too many. Now we've been asked what's the greatest number of chickens he can keep in the field. The greatest number he can keep in the field, so they've got enough space, would be 54 chickens. And that's it, the answer is 54. And that's it. And if you got that, well done. Okay, let's have a look at our next question, question number 10. So question number 10, it says, B's making a logo for a club in school. So this is the logo she's designed. And we've been asked to work out the area of the logo, and it's a calculator question. And as you can see here, we've got a trapezium and we've got a triangle. So we do need to calculate the area of this trapezium here and the area of this triangle. And then we'll find the area of each of them and then add them together, and that'll be the area of the logo. So let's start off with the trapezium on the top. The area of a trapezium is equal to half bracket a plus b multiplied by h. And that's half of the sum of the two parallel sides. So in this trapezium, the parallel sides are the top and the bottom. So we're going to do a half of 6 plus 12, close brackets, and then times by h. That's the distance between the two parallel sides. And in this question, you can see the distance between them, the height of this trapezium is 6 centimeters. So multiply by 6. That's a calculator question, so you could type this in your calculator, a half of brackets, then 6 plus 12, close brackets, multiply by 6, and that'll give you the area of the trapezium. Or you could do 6 plus 12 is equal to 18, half that's 9, and then times by 6 is equal to 54. However you wish to do this, but the area of the trapezium will be 54 centimeters squared. And again, you could just type into your calculator a half bracket 6 plus 12 close brackets multiply by 6. So that's the area of the trapezium, 54 centimeters squared. Now we need to find the area of the triangle. So the area of the triangle, for the triangle, the area is equal to half the base times the height. So half the base times the height. The base of the triangle is going to be 12. If we turn our heads around or spin the triangle around, the base of it's 12. We now need to find the height of the triangle. So that's the distance from the base to the highest point. So this distance here, the perpendicular height. Now the height of the whole shape is 15 centimeters. And if we do 15 take away 6, 15 take away 6 is equal to 9. So that means this distance here must be 9 centimeters. So now we've got this triangle, we've got the base and the height of the triangle. So now we just need to do a half the base times the height. So we could do a half of the base, which is 6, and then times by 9 is 54. Or we could just do a half multiplied by the base, which is 12, multiplied by the height, which is 9, and do it on our calculators, and that'd be 54 centimeters squared. So there, the triangle is also equal to 54 centimeters squared. So that's fantastic. Now we just need to add them together, and that'll be the area of the logo. So 54 plus 54 is equal to 108 centimeters squared. And that's it. That's the area of the logo. Okay, let's have a look at our next question, question number 11. Okay, so question number 11, we've got this shape. It says the diagram shows a rectangle with a circle cut out. So we've got this rectangle with the circle cut out. And it says the rectangle's got a length of 20 centimeters and a width of 11 centimeters. And the circle's got a diameter of 8 centimeters. And we've been asked to calculate the shaded area, work out the shaded area. So to do that, what we're going to do is we're going to work out the area of the whole rectangle. So we're going to do 20 times 11. That'll tell us the area of the whole rectangle, which is 220 centimeters squared. That's quite nice. Then we need to find the area of the circle and take that away from the area of the whole rectangle, and that'll tell us what's the area of what's left. So let's do that. So the area of a circle, area equals pi r squared. Remember, circumference is pi times diameter, but area is pi r squared. So we're going to do pi r squared. So we're going to do pi times the radius of the circle. So that's halfway across. So halfway across the circle will be 4. So we're going to do 4 squared. So we're going to do pi times 4 squared on our calculator, and pi times 4 squared on our calculator is equal to 16 pi, so 16 pi centimeters squared. You could leave it in terms of pi, or as a decimal number. If you read it as a decimal, that'll be 50.26548246 centimeters squared. So that's the area of the circle. And we've been asked to calculate the area of the shaded region. So what we need to do is take the area of the whole rectangle, which is 220, and subtract the area of the circle, which is 50.26548, and so on. Now that's on my calculator display already, so I'm just going to type in 220, take away answer, and that's equal to 169.7345175. You could have just typed in 220, take away 16 pi, and that'll give you the same answer as well. And then we need to give our answer to the two decimal places. So the two decimal places, this will be 169.7, and then the second decimal place will just be 3, because that's a 4. We're not going to round up, so 73. So it's 169.73 centimeters squared, and that's it. Okay, let's have a look at our next question, question number 12. So question number 12, we've got this diagram. It says shown as a cross-section of a river, so it's not drawn to scale, obviously. And we've got this little sketch, and we've got a trapezium, a rectangle, and a triangle. And the question says calculate an estimate for the area of the cross-section of the river by considering the trapezium, the rectangle, and the triangle, because obviously, as you can see here, this rectangle doesn't follow the riverbed exactly, but it's pretty close. So we're going to find an approximate or an estimate for the area of the cross-section of the river by working out the area of this trapezium, rectangle, and triangle. Okay, so let's label them A, B, and C. So let's start off with A, the trapezium. So with the trapezium, so shape A, the area of a trapezium area is equal to half, and then in brackets A plus B, close brackets H. So that's adding together the length of the two parallel sides, half in it, and then multiplying by H, the distance between them. So if we have a look here at this, we have our trapezium. Let's turn our head sideways here. So we've got the two parallel sides here, the 2 meters here, and here that's 4 meters, so 4 meters. So they're the two parallel sides, the A and the B, and the H, the distance between them. Well, if we turn our head sideways, the height of the trapezium will be 2.1 meters. So let's work this out. So that's equal to a half. A plus B, that's going to be 2 plus 4, and then multiplied by the distance between them, which is 2.1. Let's just check I've written that down right. Yeah, 2.1. Yep. And now it's a calculator question, so we can just type this in on our calculator. A half, and then in brackets 2 plus 4, and then close brackets multiplied by 2.1. And when we do that, we get an answer of 6.3. So 6.3 meters squared. That's this area here, 6.3 meters squared. Now, in terms of the rectangle B, that's nice. That's just going to be 10 times 4. So 10 times 4 is equal to 40 meters squared. That's easy. That's great. And then we've got C. C is this triangle. So we want to find the area of this triangle. So remember, the area of a triangle is half the base times the height. I'm going to turn my head around. So this is the base and this is the height. You could actually turn around this way. So this is the base and this is the height, because it's a right angle triangle there. But we're going to do a half of 4 times 4.5, or a half of 4.5 times 4. So let's do that. So C, the area is equal to half the base times the height. The base, well, let's call that the base 4.5 or 4, is up to you. So half times, it's a calculator question anyway, 4 times 4.5. And if we do it on our calculator, a half times 4 times 4.5, that's equal to 9. So 9 meters squared. So the area of the triangle is 9 meters squared. So now we want to find an estimate for the area of the cross section. So the area of this part is 6.3 meters squared. The area of this part is 40 meters squared. The area of this part is 9. Let's just add them all together. So that's 6.3 plus 40 plus 9. And whenever we work that out, that's going to be equal to, it's a calculator question, you can just type that into your calculator, and it's equal to 53.3 meters squared. And that's it. And if you got that, well done. Okay, let's have a look at our next question, question number 13. So question number 13 says, shown below is a compound shape made from a rectangle and a semicircle. So we've got this rectangle and we've got the semicircle, and we want to find the area of the shape. So we want to find the area of this shape. So we're going to find the area of the rectangle, and we're going to find the area of the semicircle, and then add them together. So let's start off with the rectangle. That's going to be 15 multiplied by 8, and 15 multiplied by 8 is equal to 120 centimeters squared. That's quite nice, 120 centimeters squared. Now, in terms of the semicircle, what we're going to do is we're going to find the area of the whole circle. So we're going to turn it into a whole circle. No, that's not the best of sketches, but pretend it's a whole circle. And we're going to find the area of the whole circle, and then we're going to divide by 2. So in terms of the whole circle, the radius of the circle, remember the area of a circle, area is equal to pi r squared. So we're going to find the area of the whole circle by using pi r squared, and then divide by 2. And that'll be the area of the semicircle. So in terms of this, well, the diameter of the whole circle, well, the base of the shape is 8 centimeters. That means that this will be 8 centimeters. That means the radius will be 4 centimeters. So we're going to do pi multiplied by 4 squared. And when we work out pi multiplied by 4 squared, that's equal to 16 pi, or as a decimal number, but that's equal to 50.2654846 centimeters squared. So that's the area of the whole circle. But we just want to find the area of the semicircle. So what we're going to do is we're now going to divide by 2, and that'll tell us the area of just this part here. So we're going to take our 16 pi and divide by 2. That'll be 8 pi, or our 50.2654846, and divide by 2 on our calculator, and that's equal to 8 pi, which is 25.13274123. So the area of this semicircle is 25.1327 and so on centimeters squared. Now we want to find the area of the whole shape. So the area of the rectangle is 120. The area of the semicircle is 25.132 and so on. And let's add those together and see what we get. So that'll be equal to 145.1327412 centimeters squared. And the question doesn't say to give it any certain number of decimal places, so I'm just going to round it to 2 decimal places. So that'll be 145.13, and that's it. So 145.13 centimeters squared, and that's it. That's the area of that shape. Okay, let's look at our next question. Okay, so question number 14. Question number 14 is a non-calculator question, so I've put the calculator down, and we've got this L shape, or looks like an R shape, just spun around, and we've got all measurements are in centimeters, so this is 3x centimeters, 2y centimeters, and so on. And we've been asked to find an expression for the area of the L shape, so we want to find an expression for the area of this L shape. So what I'm going to do is I'm going to split it. In terms of splitting this, I'm going to split it horizontally here, because I can do 3x times 2y to be the area of this rectangle, and I can do 3y times x to be the area of that rectangle. Now I could have split it this way and worked out the area of this rectangle and this rectangle, but then I'm going to have to work some stuff out. I'd have to work out the length of this side and so on. But what I'm going to do is I'm just going to split it across this way here. So in terms of this rectangle here, I'm going to call them A and B, so A and B. So in terms of actually this rectangle here, A, the area of A, it's a rectangle, so the area is equal to the length multiplied by the width. The length of the rectangle is 3x, multiplied by the width of the rectangle is 2y. And 3x times 2y, well, 3 times 2 is equal to 6. And then we've got xy, so xy. So that means the area of this rectangle will be 6xy. That's the expression for the area of that rectangle. Now in terms of this rectangle B, so B, the area again is equal to the length multiplied by the width. The length of the rectangle is 3y. The width of the rectangle is x, so multiply by x, and multiplying those together is equal to, well, 3 will just be 3, and then we've got yx, or in alphabetical order, xy. If you need to recap this, if you go to Corbettmaths and look at multiplying terms, it'll go through how to multiply algebraic terms like this. So if you haven't seen multiplying terms like this before, that video on multiplying terms on Corbettmaths will be really useful. So the area of this rectangle, an expression for it would be 3xy. So we've got the area of this one is 6xy, the area of this one is 3xy. If we add them together, that'll be the expression for the area of the whole shape. So 6xy plus 3xy, well, 6 lots of xy plus 3 lots of xy would be 9 lots of xy. So that's the expression for the area of that shape, 9xy centimeters squared. And that's it. Okay, let's have a look at our last question, question number 15. So question number 15 says a garden ACDF. So ACDF is a trapezium. So as you can see, it's a trapezium. You've got your two parallel sides, AC and FD, and we've got the distance between them being 12 meters. And we're told the garden is divided into two sections. We've got this decking region and we've got this grass region. We've got a square area of decking. This is a square area of decking, so it's a square. So if this is 12 meters, this length here will be 12 meters as well, because this is a square area of decking, ABEF, and a section of grass, BCDE. And we're told the AC, so the distance from A to C, is 46 meters. This is fantastic. If I know the distance from A to C is 46 meters, 46, take away the 12 that we know there, because it's a square, is equal to 34 meters. So that means the distance from B to D would be 34 meters. Okay, so we've got that distance. Then the question says the ratio of FE to ED, so FE to ED is 2 to 3. So for instance, if that was 2 meters, that'll be 3 meters. If that's 20 meters, that's 30 meters. That's the ratio of those sides. And we've been asked to find the area of the garden. So if we want to find the area of the garden, what we're going to want to do is find the length of, well, the area of the square is straightforward. The area of the decking, we're just going to do 12 times 12. And 12 times 12, 12 multiplied by 12 is equal to 144 meters squared. So the area of decking is 144 meters squared. But we need to find the area of the grass, because if we find the area of the grass, we can add that to the area of the decking to get the area of the whole garden. Now the area of the grass, this is a trapezium, and the area of a trapezium is a half. The area of a trapezium is equal to a half A plus B close brackets H. And that means the sum of the two parallel sides, so that's going to be 32 plus this distance here. We're then going to half that and then times about the height, the distance between them, which is 12. So we need to find the length of this side here, this ED. Okay, so to find the length of ED, well, we know that FE is equal to 12 meters. This is a square. And we want to find the length of ED. Now, we've got a ratio here. The ratio of FE to ED is 2 to 3. So if we take the 12 and divide it by its number in the ratio, so if we take our 12 and we divide that by 2, that's equal to 6. And then we can multiply by the ED's number in the ratio. And then if we do 6 multiplied by 3, that's equal to 18. So that's equal to 18 meters. And if we check this, if we've got 12 to 18 as a ratio, if you cancel it down, you'll get 2 to 3. And that's the ratio we had. Okay, so if we have a look here, we've got this trapezium. We've got the length of the two parallel sides, 18 and 32. We've got the distance between them. We can find its area. And then once we find the area, we can add on 144, and that's the area of the whole garden. So let's do that. So in terms of the trapezium, it's a half. The two parallel sides, the lengths of those are 34 and 18, so 34 104 plus 18, and then times by h, the distance between them, which is 12, so multiply by 12. And then if we just work this out on our calculator, a half, and then in brackets, 34 plus 18, close brackets, multiply by 12, that's equal to 312, so 312 meters squared. So that means the area of grass in this garden is 312 meters squared. And that's fantastic. To find the area of the whole garden now, we can just add this number, this area, and this area together. So 144 plus 312. So 144 plus 312 is equal to 456. 456 meters squared, 456 meters squared, and that's it. And that's it. So these are the video solutions to the area of compound shapes practice questions. If you need any extra help on this topic, if you look at videos 41 and 42 in Corbettmaths, they'll be useful for you. But this video will focus on the video solutions to the practice questions. I really hope you found it useful. If you have found it useful, please like the video. Please subscribe to the YouTube channel. Thank you. Cheers.